Okay, welcome everyone to today's professional development seminar on presenting your thesis in 3 minutes or less. So today's seminar will be hopefully especially helpful to anyone who is participating in the 3-minute thesis competition next week. Is anyone here signed up for 3MT? Few, awesome. But even if you're not participating in that competition, it should be helpful in providing you with some helpful tips in more effectively communicating your research when you're just interacting with people you meet at conferences or in more casual situations where you don't have 3 or 4 hours to explain your whole thesis or dissertation to them, but just to give someone a general overview of what it is that you're working on. So we have 3 presenters here today to cover a variety of topics with you, and we'll start with Ms. Sarah Hancock, who's the communications coordinator for the Vice President of Research Office. And just a reminder for if you're working towards the professional development certificate offered by the Graduate Student Council, just make sure you checked in with Kelsey when you came in, and then after today's seminar, as early as later today or within the next couple days for sure, you'll get an email with a link to do a survey, and you'll need to complete that post-event survey to get credit for the certificate. It's just a brief few question survey to get some feedback on the seminars we're offering. So I'll turn it over to Sarah.
Thanks for being here today, and congratulations for making it from wherever you had to walk from without your blanket. I'm wearing mine. It's nasty out there. So I'm going to talk a little bit today about some tips that really, like Megan said, will help you with the 3-minute thesis or would be helpful in lots of other communication situations, lots of rhetorical situations that you're going to face as a researcher. Oh boy, how do I make this go?
It might just not be on.
Is it this?
It is on.
Aha, what'd you do? Just
Click
click?
the-
Okay. Anywhere in the slide?
Yeah.
Okay.
It's just a few.
We'll see.
Yeah.
You're right
You can
there.
just-
So, all right. So in 3-minute thesis, we're talking to general audiences, right? So that's one of the first things that you need to know about it. Your judges are not going to be experts in your field, maybe not scientists at all. So you need to be prepared to talk to non-expert audiences. And this is analogous to that grandma chapter of your thesis. That's what Vice President for Research Dorhout likes to call it. Talk to your grandma. How are you going to tell her about what you do? So this is a bunch of stuff from the 3-minute thesis website. I thought it would be good to check in. You know, one of the first things that I always do if I'm going to edit or prepare a presentation, an abstract, read the rules, right? And when I was a writing instructor, the thing that I would tell my students is the first thing you need to do is read the assignment, and then probably read the assignment again. So right from the 3-minute thesis website, you're supposed to avoid jargon and make sure you explain all of your concepts, because you may be referring to something that someone outside your field isn't familiar with. Highlight your outcomes and desired outcomes. You need to convey what's exciting to you about your research, and we're going to talk a little bit about building that sort of emotional connection. That's a real secret to success in a competition like this. If your judges do not feel some kind of fire or emotion from you, you're going to have a hard time connecting with them and doing well in the competition. Telling a story, I'm going to talk a little bit about storytelling, and my colleague Nikki is going to expand on that. And then kind of in terms of organizing your talk, writing an attention-getting opener, highlighting your different points, and stating the importance of your work. So note that right there you have a basic organization for how this talk should be set up, right? Attention-getting opener, highlighting your points. So you need to have some roadmaps, some signposting. Did anybody in this room ever participate in competitive speech events when they were in high school or in college as an undergrad? No? Okay, I have kids who do this in high school. They do what's called forensics, and there's extemporaneous speaking and informative speaking and oration and lots of other events. And this is one of the major things that these students learn to do, is how to organize a speech with minimal preparation time and how to then deliver it in a way that a judge can understand and can follow where they're going to go. So you only have 3 minutes. It needs to be very clear exactly what you're saying and the order that you're going to say it in, and your judge has to be following you, right? So in stating the importance of your work is something we're going to work on here in a minute too. Here's some other advice. Know what you want your audience to take away. So what's like the one thing that you want that person to remember, right? What's the most important thing for the audience to know? Help the audience understand what you're doing, why it's important, and what you hope to achieve. Again, note that there's kind of an implicit emotional connection there. What are your hopes, right? As a person, as a researcher, as a scientist, what are your hopes? So it's not just, that cold delivery of, methods and results, right? But what are your hopes? Practice and get some feedback and make sure that your presentation is clear and that it really highlights what your research is about and why it's important. Finally, okay, this is the last slide, but they have a lot of stuff. If you guys haven't looked at the 3MT website, you need to take a look. Personal touches, again, how are we going to know you as a person, right? Use some creativity. So this is a little bit about your slide, and Michael is going to talk more about how to choose a successful image and how to connect with your audience using your image. And then think about how your slide might assist with your format and delivery. So how do you use the slide to make you a more successful speaker? So more about that will be coming later. I will note that it asks, is there a metaphor that helps you explain your research? We'll talk about that a little bit more here in a bit. All right, so in any science communication, and any of you who have been in any of the trainings that I've delivered in the past about science communication, this is a slide that I've used a lot because this is what AAAS says to remember about the difference between how a scientist communicates and how a member of the general public communicates. So a scientist wants to go with background and supporting details and then results and conclusions, whereas it's completely flipped. For members of the general audience. So, this is a situation where you really have to shrug off the scientific convention. And it's not because there's anything bad or wrong about this, because as we know, it's important. I mean, it's crucial, right, that science proceeds the way it does. But the way that we communicate about it has to get changed for a situation like this. So we're going to go with the bottom line first, and then answer the so what question. And then if there's time, then we're going to provide some supporting details. There's not really going to be time for that in 3MT. All right, so how do you do all of that stuff? That's what we're here to describe. So the most important, or one of the most important things you can do to get started as you're planning your 3MT or any kind of talk is think about what kind of story can you tell. So I have a book up here on the slide. And maybe some of you have read it, The Moral Life of Henrietta Lacks, telling the story of HeLa cells. Has anybody read this book? It's long, okay, so it's no kind of model for 3MT necessarily, but this is telling a story, and it's a really good example of science communication in a long format. So that's why I have it on the slide. But some crucial elements to telling your story is conveying why you became interested and how. When was the moment that you chose to study what you're studying and do the work that you're doing? What's weird or surprising about the work that you're doing, right? These are prompts to get you thinking. So what's weird or surprising? A lot of science is pretty weird or surprising, right? And a lot of science journalism capitalizes on that very well. My husband sent me an article earlier this morning that said researchers have found that some kind of compound that is in fryer oil at McDonald's has been shown to help regrow hair on mice. So it's like baldness medication in French fry oil. Now that's weird and surprising, right? And so that's the kind of thing that gets the science headlines. And I'm not saying that that's always great, because sometimes that stuff is really stupid. And scientists get really annoyed sometimes with popular journalism for coming up with, what's the stupidest thing you could say about my research, right? But that's what the general audience will stop to read, right? So think about what you can find to say that's odd or surprising. Or another way to think about this is, what's the tension? What's the tension in your field? What's the tension in your work? You know, is it, you know, we know that X is going on, but we don't know if Y or Z cause X. And so the tension is, I'm trying to decide, I'm trying to decipher, you know, build evidence for or answer this central question. So identify what the source of tension is, and that's going to help your audience understand what you're trying to do. And then finally, we come back to this human side. What are your motivations and what are your hopes? A lot of scientists have some fairly personal motivations. You know, maybe you're working on some kind of mechanism that is going to shed light on Alzheimer's research because your family has been affected by Alzheimer's. Or, you know, maybe you grew up loving to fish and you want to do fish biology. I don't know. But, you know, what's your motivation? Is there something in your history that can connect with your audience? Okay, so I have a little worksheet for you here. Do you want to move these around? That have some storytelling prompts and some fill in the blank. So the prompts are some of the things that we just talked about. So you can fill those out a little bit. And then you can also take a look at these fill in the blanks. So there are 3 different starting points, and you can pick the one that makes the most sense to you. So one of them is, nothing in blank makes sense except in light of blank. So the first one is your field or your subspecialty, or, you know, some subspecialty, whatever the specific item is that you're studying. And so what do you have to explore to make sense out of that? So that's one prompt. And then another one is, what you're studying is blank, blank, and blank. And these are just adjectives. So how can you describe what you're studying in a way that makes it sound interesting and appealing to someone outside the field? And so you don't just want to say it's difficult, obscure, and, you know, you want to come up with something that makes it sound a little livelier. It's intriguing, maybe. It's crucial. I mean, maybe you're studying something that is going to help fight disease or help ensure food security, you know, and so think about, how are you going to describe that? And then there's also, this is stolen from a prominent science communication expert named Randy Olson. He uses the ADT format, and, but, and therefore. And he says any good piece of science communication proceeds according to this. And then he actually takes science journalism and kind of highlights, you know, where in the first couple paragraphs is it and, but, and therefore. And it really does, if a piece of writing is effective, a piece of science communication, it often does conform to this format. It's pretty interesting. So blank and blank, but blank, therefore. And, you know, this could be the entire structure of a 3-minute thesis, right? So I want to give you just a couple of minutes to look at your storytelling prompts, or at these 3 starting points, and choose a couple of them and try to fill them out in a way that you think will help you. Okay, so 1 more minute. See what you can fill out in 1 more minute. And we'll share some examples. Okay, so who has a story of how you became interested in your research topic that you would share with the group? Does anybody have a quick 1-sentence summary of how you became interested? Yeah?
A talk by my future advisor. That was it.
Your advisor?
Yeah,
And
so
so
I'm gonna talk, and it was really interesting, so I wanted to learn more.
okay, so you had an influential person in your life.
Yeah.
And so that sounds a little bit like you could unpack that somehow. You could say, you know, were you an undergrad?
No, it was here at grad school.
You were in grad school? Okay, so I was in graduate school and, you know, maybe I kind of thought I knew what I wanted to study and I was, you know, kind of exploring, and then I heard someone give a talk and it really captured me, right?
Mm-hmm.
I mean, I think that's something a lot of people can relate to. So that's a good story. You can add detail and make it more interesting. Who else has it? Anybody else? A personal reason for studying what you're studying? You guys need to work on this, right? Okay, how about something that's weird or surprising? What's weird or surprising in your field or in what you're studying? Nobody's doing anything weird here. It's all just cut and dried.
Well, my fun fact is that a donut and a coffee mug are the same thing to me.
A donut and a coffee mug are the same thing to me.
To me, not to you.
That's great. I would love to hear more about that. So I think that's a really nice opening line of a 3-minute thesis, as long as what you say after that makes sense. Yeah. Otherwise, it might be kind of surreal, right? You could put a melting clock up on your slide. It would look great. Yeah. Okay. So those are a couple of good examples. How about the tension? Is there a central tension in your work, or a question you're trying to answer, or a tension in your field between, you know, maybe competing explanations for something? Does anybody have an example from that one? Is everybody shy in here or what? Okay, yes.
So my research is about imprisonment or children with imprisoned parents. And the literature is kind of torn between, is it because children with incarcerated parents, they perform worse than other kids? Is it because of the separation from parents? Or is it because of the drug abuse or neglect that they experienced before the incarceration?
That's a great example.
Yeah.
That's a great example. So the literature is divided, and so I'm trying to sort this out. Very good. Very good. That's an excellent example. And then how about your motivations and hopes? Does anybody have a really motivating principle or a hope that you would share with the general audience? If you don't have one, you need to get one. I mean, you need to be able to explain what keeps you going. I mean, besides, like, I just want to get my degree and get out of here. That's not very, that's not very satisfying for your audience. Yeah.
I'll give you a hope, because I think I have that one down. I hope that we can sustain life here on Earth.
That's a great thing to hope for. I mean, I think we've all got to hope for that, right? So I think that's a good example. Yeah. Okay. Nothing in blank makes sense except in light of blank. Does anybody have one of those? That might take a little bit more thought. Does anybody have an example to share? Okay. How about adjectives for what you're studying? Who's come up with some wonderful adjectives? Anybody? Yeah.
Bacterial competition is deadly unknown and surprisingly dynamic.
Deadly, unknown, and surprisingly dynamic. Ooh, that sounds intriguing. Yeah, I like that. How about the ABT? Who took a stab at ABT? That might take a little time too. Does anybody have an example to share? Okay, take that one on board and try to work on it because it really will help you organize your talk. Okay. So the other tool that I brought around while you were working is a basic messaging triangle, and who has used one of these before? This is very basic, a very basic science communication tool that is designed to help you persuade general audiences. And you put in the middle of the triangle what you want the audience to know, believe, or do. And then you design 3 points that are going to help you persuade your audience, okay? And so, you know, if you're going to do a good 3-minute thesis, you should think of it as a rhetorical situation in which you're trying to persuade someone of something, because that will make it better, okay? If you're just doing straight information, that's going to be a little bit harder to really excite people, right? So using it as an opportunity to persuade somebody that, you know, we want to sustain life on Earth, and here's one of the ways we're going to do it. And you know, here you should go out and take action to help us do that. That's more exciting for people, right? More exciting for your audience. So the other crucial thing about this is framing your message. So this is where knowing your audience comes in. You need to think about how you're going to frame a message for a general audience. And this is hard for scientists to do sometimes. But what kinds of information do people really care about? What are people really affected by? If I'm going to frame a message to the general public, how am I going to talk to them about something? How do commercials talk to us? If there are lots of advertisements for products, one of the main things that people are going to advertise on is a product that's going to do what for you? It's going to benefit you. How might it benefit you? In everyday life, by maybe saving you money, saving you time, making your life better, making you safer, making you healthier. So what kind of frame can you put around your ideas, and that helps you focus your argument really tightly? So are you going to adopt the economic frame and talk about how you can, you know, how your research is ultimately going to save people money? Are you going to adopt a health frame? How's my research going to make the world healthier, make people healthier? Those are the two that really matter to people. National security, food security, international security, some things like that might help. The education frame is very meaningful to people. So what kind of frame are you going to put your research in? And then design your points around that. So we're not going to take the time to fill this out right now, but there is a sample on the other side that's about RNA interference, which is kind of a hard thing to talk about because people hear that and they think genetic modification, which it's not, but it's, you know, in that danger zone of creating Franken foods or Franken critters, or, you know, so it's a tough science communication topic. So there's an example on the other side. It's not perfect, but it's solid, and it has some good points. So it's a little bit of a model for you to look at. So answering the so what question is one of the most important things to do. We've talked about that. This will help you answer that so what question because you already have your frame built in. Okay. All right, so some pitfalls to avoid as we're going along here. We have our friend Sheldon up here on the screen because Sheldon suffers from the curse of knowledge. So because he can't just make a simple explanation for anything, you guys have all seen Big Bang Theory, and Sheldon, you set him off and he can't talk, he can't tell anybody one thing for 30 seconds. He has to talk for, 2 hours to explain anything. So avoiding the curse of knowledge is really crucial in 3-minute thesis because you do not have time to tell everything that you know. So how are you going to do that? How are you going to winnow down what you're going to say? Another thing to avoid is an awkward, forced, or orphaned analogy. So an awkward analogy is one that just doesn't really make sense, or a forced analogy. You're trying too hard to come up with an analogy to help people understand what you do. If there's an analogy or a metaphor that leaps out at you that you think is really useful and helpful, then by all means go for it. But don't force one onto the material because it'll be clunky. So work on the other storytelling prompts if you don't have a baked analogy, if there's not something that's just easy to do. The orphaned analogy, I've heard people do this because I've been a judge for 3-minute thesis in the past, and I've heard people do this. They walk out, they put up their slide, they open with a great analogy, and then they go right into the science, and they never talk about the analogy again. If you're going to use an analogy, it has to be carried throughout. And you have to, at the very least, lead with it and end with it, right? You don't just throw it out there and then just move on and just let it be an orphan. So it's better not to use one than to use one poorly. Disjointed transitions make it difficult to follow a speaker. So this is where it goes back to that organization that we talked about earlier. Highlight your points. And if you have to do that by saying 1, 2, 3, first, second, third, it might sound clunky to you in your head as you're speaking, but it helps your listeners understand where you are in your speech. So make sure you put in some transitions. Lacking emotion is going to leave your audience a little bit cold. So effective messages, here are some things that they do. So keeping our claims simple and backing them up with evidence. That's what this is going to help you do, okay? And then also building trust and rapport. So going after hearts and minds rather than minds and hearts. And this is a slide that a friend of mine in K-State Research and Extension uses to talk to extension educators about how they go out and communicate research to the public across Kansas. We're land grant, so we do that. We have a big bunch of people who are all over the state, and that's their job. And so he likes to remind them of, kind of how people make their decisions based on fear and emotion and thinking. But there are 2 things that kind of work on based on emotion, and those things require less processing than the higher brain system. So it's important to remember, if you want to connect with people and motivate them, you're going to have to build that emotional connection. Now, that doesn't mean you scare people. That doesn't mean you scare people, but it might mean that, you adopt a health frame and you talk about, how people are afraid of contagious diseases, or you maybe capitalize on what people can see in their own environment. If you want to talk about, making life on Earth sustainable, talk about some of the challenges of drought in our agricultural state or something like that. So think about how that plays into what you're going to say. So in terms of organization, this is, remember what 3-minute thesis said. So all of this is designed to get you started, but your central challenge is still going to be to organize how you use your storytelling information and how you use your triangle, the items that you put on your triangle. So remember that this is how 3-minute thesis recommends. So take what you've generated today and then trim it and organize it and try it different ways, okay? Make some different versions. When you have 3 minutes, you're going to have to trim and give it a shot, and then trim and give it another shot, maybe rearrange, right? And my final piece of advice is the old joke. Maybe you guys have heard this one. How do you get to Carnegie Hall? Has anybody told you guys this bad joke? It's one of my husband's favorite jokes. How do you get to Carnegie Hall? Practice, practice, practice. You guys know what Carnegie Hall is? It's one of the world's foremost locations for classical music performances. So getting to Carnegie Hall is kind of like you're at the apogee of music performance. So you're not going to get there unless you've practiced. So 3-minute thesis is not going to work out well for you if you don't practice. Okay, so I'm going to hand this off to Mickey now. I don't know what needs to happen there. I didn't break it there.
All right. So I'm Mickey. I'm Mickey Tobler. I'm a professor here in the biology department, and essentially I want to, I think, largely overlap with my messaging in terms of Sarah just told you, but I'll just maybe give you a slightly different spin. I think you guys are all trying to become scientists, right? And as a consequence of that, you're basically being inducted into this highly ritualized society of scientists. You learn new languages, right? Very specialized language that allows you to efficiently communicate with your colleagues. And whenever you present your research, you basically have to comply with very specific conventions, both when you go to a conference and when you try to publish a paper, right? Like if you haven't published a paper yet, you will learn that it's a major nightmare, because there's like 15 pages of instructions to authors that determines exactly when you're allowed to use a comma and exactly how you need to write your references, and so on and so on and so on. And this all has a purpose, right? It makes communication among us efficient. We want to, when you're talking to other experts in your field, you have a highly specialized language that minimizes misunderstandings, right? But it's exactly you becoming a specialized communicator that, if you're not careful, makes you less and less apt to actually communicate your science to people that are not in your field, right? And so the first point that I want to make, that Sarah, of course, has also made, is that you have to know your audience. And that's true for your 3-minute thesis competition presentation. And that is true when you go to a scientific conference in your field. You cannot assume that you're speaking to a room full of experts, even when you're a developmental biologist and you go to a developmental biology conference, because there's so many specializations within all of our fields, right, that you have to be cognizant about what you can actually expect your audience to understand. And to make this point a little clearer, I have this maybe crappy analogy. I don't know whether it's going to work or not, but imagine this is the circle of knowledge, right? And we all start out equal. We all go to the same schools. It's the equal opportunity model of education that's at the basis of our democracy, right? We all learn to read and write and interpret basic facts, right? And the circle of knowledge, at least it's supposed to, should grow equitably. We all learn the same things until eventually you graduate high school, you go to college, maybe do vocational school, and you start to specialize, right? And you guys in particular, as grad students, you have continued to specialize. You've been reading the primary literature all the way out, trying to actually get a sense, a feeling where the boundaries of human knowledge are. where the boundaries of human knowledge are. And you know, the goal really is, right, to push this a little bit. As scientists, what we're trying to do is expand that circle. And if you just push hard enough for a little while, you make a novel contribution to science, right? That's what we're all after. And after a course of a PhD, you know, you have moved that line post, you've moved your field forward. Big problem with all of this. You've been obsessing about pushing that line of knowledge forward. But the world looks like this to you, right? You're sitting at the tip of this little bubble, and you're looking out into the world. And that's the worldview of a scientist, right? In order to move your field forward, you have to focus intensely. You become very specialized. You are the expert in your specific field, right? And as a dangerous consequence, you may lose the bigger picture, right? And I think that's at the heart of problems, of communication problems between expert and non-expert audiences, right? And as Sarah said, you know, this is also known as the curse of too much knowledge. You simply cannot unlearn what you already know. And when you're presenting a problem, the danger is that you want to convey all the caveats and all the data that might you know, shed a slightly different light on your finding, right? You have, you know, done years worth of research, and some data might support one hypothesis, and other piece of data might support another hypothesis. And you're intrinsically familiar with all these complexities of your findings, of all these nuances in your data sets. But it's completely irrelevant to 99.9999% of the people, right? So the idea is really that you need to get off your little bubble there on the tip of the circle of knowledge. You have to pull back into the center of the circle of knowledge and try to put yourself in the situation of a non-expert in your field, trying to explain you know, how things actually work. And I think this cartoon describes it perfectly, right? If you live in a city and somebody asks you for direction, it's super easy. You go, you know, down the road, you take a left until you get to the roundabout, and there you take a left again until you pass the house with a big tree, and that's where you want to go. But for somebody that is not familiar with that city, they're going to be lost after this, you know, the first or the second turn, right? And that's exactly the same issue with explaining the complexities of your research to an audience that's not familiar, maybe even with the basic tenets of your field. And so in order to kind of circumnavigate that, I argue, is that the computer? I don't know. I would argue that storytelling is a really powerful tool. And I'm not saying telling a story to entertain, but actually telling a story to convey information, right? Breaking out of this habit of I'm going to give you some background about my question, then I'm going to talk for 10 minutes about the methods that I so carefully developed over the last 5 years that allowed me to do my research. Then I'll show you a bunch of convoluted graphs that show my results and give you some conclusions of what I found, right? It's breaking out of that habit and using elements of storytelling to package your science in a way that is understandable to people. And so, you know, in research, we of course have we're dealing with major components that make a story lively as well. Like, I'm a biologist. Characters I study might be different species, right? I might be investigating a certain phenomena across different species that might tell me different things. There might be different scenes, study locations in my example, for example. And there might be different plots, right? There might be different questions that I can address with my characters and in my different scenes. And so, you know, using storytelling to communicate science is really not too far-fetched if you basically, you know, have a broader definition of what characters, scenes, and plots are. And then what I'd like to do in the next 5 or 6 minutes or so is just give you 4 basic tips on how to use storytelling in science communication. And some of this is redundant from what Sarah already told you. But again, I'm hoping giving you a kind of a different spin on this might help you. Advice number 1. You got to hook your audience right away. Hook them or lose them. If you go to a 10-minute presentation or give a 10-minute presentation at a conference, if you haven't hooked your audience in the first minutes, they will start to doze off, right? They will not follow. So having an opener that grabs people's attention is incredibly important. And so you got to set the scene essentially, right? The scene where your characters play and where your plots unfold. And as Sarah mentioned, I really recommend these and, but, and therefore statements. And I'll give you a little bit more information about this and how you can actually connect or use these statements to efficiently connect to your audience. Because you have to know your audience, right? And so one good way of essentially using these and, but, and therefore statements is to state something your audience knows and state something else your audience knows. Because that allows you to connect to your audience, right? And then maybe state something that the audience doesn't know, and you can therefore justify why you're conducting your research, right? Like, we know that our planet is warming, right? And we know that many organisms are sensitive to the temperature in their environment. But we don't really know how a warming planet affects polar bear distributions in the coming decades and centuries, right? Therefore, I am studying how ice distributions in the Arctic Sea coincide with polar bear densities, right? So the critical thing here is really that you think about your 2 first statements in the context of the background of your audience. And so you have to understand whether you're at a specialized conference and you're talking to other experts in the field, or as in the case of the 3-minute thesis talks, right? Whether you're probably talking to people that have not even a basic understanding about the central themes of your entire research field, right? So it's very critical that you make your connection there right away and think deeply about, you know, how your research relates to somebody that might just have a high school degree or you know, a bachelor's degree in a different field. Is there any questions at this point? All right, a second really useful tool in storytelling is building tension, right? Every good story builds up tension that later gets resolved. And that's another really good evidence to essentially pique the interest of your audience. It allows you to basically generate curiosity, and you can do this by introducing controversy. And I'm not saying you should build a straw man, right? That, you know, you just make for the sake of an argument, but you really think about what are some of the central controversies in the field, right? The polar bear examples, well, some people say the Earth is warming and others don't. So what is really the evidence that we have that climates are changing across our planet, right? So building controversy is a means to basically keep people's attention after you try to grab it after your opening statement. And then probably most importantly, deliver a satisfying climax. You don't want your talk to end like Seinfeld, right? I don't know whether you guys are familiar with that, but you know, like everybody that loved Seinfeld loved it until the final episode aired, and then everybody hated it because it was like the worst end to a story possible. And you know, the fundamental challenge about delivering a satisfying ending to your story is really that you cannot assume that the audience can draw conclusions based on the facts that you presented. It's something that you see very commonly at scientific conferences where people show you the results and they give you like a 30 seconds, you know, in conclusion, this is what I found, and then the talk is over. The conclusions might be evident to you because you're an expert, right? But they're not necessarily evident to a general audience. You have to spell it out for them. So the concluding part is not something that you quickly talk away in the last, you know, moments of your talk, but rather that's something you build to, and you have to invest significant time to make sure you can deliver that punchline, right? And it needs to, of course, relate to your opener, right? To your initial and but therefore statement. It's only a satisfying conclusion if you essentially resolve the problem that you actually introduced in the beginning. And so every good story, right, sets a good scene, develops a plot, creates some tension, and it gets resolved. And I would argue you can do this with science talks as well. It just takes a little bit of planning in advance. Now, so by the way, it's working for me.
Good job.
I must have the
Yeah,
magical
touch.
magical touch. My last piece of advice is keep it simple. This is advice I give for 10-minute talks at conferences, right? We're talking about 3 minutes thesis. You really got to keep it simple. There's a reason why jokes usually start, there was 3 guys in the bar, and not there's 24 guys in the bar and a cat and a mule, right? Doesn't happen. There's a reason why popular movies have an easy to digest story, and that only, you know, some fringe members of the community think that Tarantino is actually a great filmmaker because, I mean, who can follow those plots, right? It might be enjoyable to watch, but if you go and ask people coming out of the movie theater after they saw Pulp Fiction, can you just explain to me what the plot of the movie was? You're going to get as many versions as you ask people, right? So you got to keep your story simple. You can, for a 10-minute talk, focus on 1, maybe 2 central tenets of your research. It means you could probably focus on 1 central tenet of your research when it comes to the 3-minute thesis, right? Don't talk about methods too much. I know scientists love methods, but it's completely, unless they're critical to your story, until they're a critical part of your plot, you can treat this superficially. When you talk to a general audience, I tell you, no one cares. They really don't, right? Unless it's absolutely critical for them to understand the methods. Otherwise, they cannot, you know, understand your conclusion. Just leave it out. And I would argue if you go to a specialized conference, make your methods as short as possible. Focus on the characters and focus on the plot, on the general findings, right? And methods have the potential to disrupt your story. And also, don't go off on tangents. You won't have an opportunity to go off tangents in a 3-minute thesis. But at conference presentations, it's very easy to go off tangents. Well, and generally my data shows this, right? But then there's this one outlier data point here, and let me tell you all about this one outlier because I find it so interesting, right? Well, you might, but nobody else probably does care about that one outlier. Unless that outlier is part of your story. Don't talk about it. Focus, right? Focus on one or two key things. So I'm trying to heed my own advice. Keep it short and focused. Here's the summary. Understand your audience, then set the scene, build tension, and resolve your story, all while keeping it as simple as possible. And I usually would now talk about using good visuals along with this, but we have Michael here that will actually do that, unless some of you have any questions about what I said. All right, it's all yours, Michael.
I just need a second to get my talk on the computer here.
You can ditch the purple one, that was mine. Good job.
I use that metaphor all the time.
You do?
It's a great one.
Good one.
Okay, so just out of curiosity, this know your audience theme that people have been hammering is one I take to heart. Is everyone here actually a scientist? Are there any artists in the room? Oh, cool. Humanities types? Social scientists? Life scientists? Physical scientists? Engineers? I'm just curious.
Nobody will admit when they're
One of you are none of the above, which is it's fine too. So I am going to go off on one little tangent right before I start the prepared part of my talk, because it's something that I think is really important for 3-minute theses in particular and similar type of things that no one else has really mentioned. Whenever you give a talk, there's always this tension between wanting to sound really prepared, but not sounding like you're reading off a script. And this is something that's really hard. In longer talks, it tends to be a bit less of an issue because there's very few people who can actually like write out a script for a 50-minute talk, and you usually just fall into natural habits of speech. But for a 2-minute, a 3-minute sort of thing, you have to rehearse this extensively to actually have it fit reasonably neatly in the length of time allotted. But you don't want it to sound like you are literally reading off word for word. So this is tricky. So you want to practice it, but you want to make it sound like you're just so naturally brilliant that this is how you talk off the top of your head. So different people may have different ways of resolving that tension, but it's something that you want to keep in mind. And so I haven't done a 3-minute thesis, but in my department, we, for our graduate recruiting event, when we have candidate PhD students coming in to visit, we do what we call faculty data blitz, which is all the participating faculty members get 2 minutes and 2 slides to get across the essence of their work and hopefully convey why they're an interesting, dynamic person that people should want to work with and ideally come to K-State to work with. So it's been very informative both to do that, but I've also helped run that program in the past. And you'd be amazed how many people, like serious scientists, these people have like tenured positions, show up and actually haven't practiced the thing and end up 2 minutes, they're like halfway through, and then I get the joy of dragging them off stage. So this is definitely something, like other people have said, that you want to rehearse. Now, whenever I give a talk, or giving talks in general, if you have slides involved, one of the key things you have to think about is how much information is on any one particular slide. So you'll often hear this rule of thumb, oh, you want about 1 slide per minute of your talk. And this in general, I think, is total garbage. So when I talk, when I teach undergrads, for example, you know, in general, they don't know much. So I need to spend a lot of time explaining everything. So I'll often spend several minutes on each slide. So often my 50-minute lectures, I'll only actually go through maybe 25 slides or so. Conversely, when I give research talks, I put a premium on making every single slide as simple and straightforward as possible. So my postdoc mentor used to drive me mad. All his slides were these really elaborate multi-panel sorts of things. You'd spend 5 minutes on each one, but each key little thing would just be one little panel. I hate that. I would rather split that figure up, show each panel separately, strip out everything extraneous to the thought I'm trying to convey at this one particular moment. So I will often give 50-minute talks that have 100 slides or more. And it works fine as long as those slides are pared down so that that it's just the bare essence of that little moment in time in your talk. So you may say, okay, this is completely irrelevant to the topic at hand, right? Because you only get one static slide. But it's not, because you have to make very careful decisions about how much information you put on that slide as opposed to how much information you convey orally or in the form of interpretive dance or whatever you do in your presentation. So for most people, you're probably going to have some sort of balance of text and then maybe some images or graphs or visual aids of some sort or another. But there are many, many ways to skin this particular cat. I could imagine people giving great 3-minute theses presentations with no visual aids whatsoever. I could imagine people doing a great job just with some sort of simple declarative statement that frames what they're talking about. I can see people doing a great job just with an image and no text at all. There's many, many ways to go about this. But one informative way to think about it is okay, what would I do if I was doing something like this? So I probably would want some text on my slide. It wouldn't necessarily be the topic of my thesis, because the topic of your thesis is probably like role of gene A in boring process B in cell type C. It's something dry, it's detailed, you care about it. That may not be the take-home message that you want other people to take away, both in terms of what you're talking about, but also in terms of what is up on the board that they're looking at while you're talking. So for me, I would probably say something about how do genomes control animal body plans? That's the overarching theme of my lab's research interests. In practice, what we do is much narrower than that. This isn't a question that I'm going to single-handedly answer, but it's why my lab is doing the things that we're doing. And I think similar things would be true for most of you too. In terms of Miki's sphere of knowledge, which is a great metaphor, you're poking out this tiny little point. But the reason that it matters is partly from stepping back to the middle of that sphere, but in general it's like that zone kind of slightly broader, it's your subfield. And so you want to frame things in terms of that. Whenever I do anything like this, it's always good to let people remember your name, let them have a sense of where you're from, and I always like to actually include an email, just because I often hope that, no one ever does, but every once in a while someone actually emails me to say, they have a question or they want to collaborate with me or whatever, it gives them the chance to do that. All right, so my work's pretty visual, so I would definitely put an image on it. So this is an image I use all the time in a lot of my talks. I won't go through what it is or the details of it, but it's something that's fairly iconic for me and that I'm able to use to introduce what I work on and introduce some of the key questions. But beyond that, it's a cool image, right? You don't have to know what this is, and you're like, cool, what's that? And that is something you should strive for in the images you use in your work. Even if it's not immediately intuitive what it is, it should be cool looking, right? It should be something that you could imagine putting on the wall in your office. Just for its own value, regardless of whether it's key to explaining the scientific story you're starting to tell. So whenever you use an image and whenever you use text, give some thought to just how big you make things, how big you make the text, how big you make the image, how much white or black space you leave between them. In general, most people show images too small. why have this thing as a tiny little thing here and then this giant text wasting lots of space? Let's just make some minor adjustments here. Now I've got the actual picture way bigger, so it kicks you in the face even if you're in the back of the room. The text is a bit smaller, but it's still big enough to read, and I've just kind of moved things around so they actually look pretty. And I'm not going to talk about graphic design today. I'm not a graphic designer. But in general, you know, it takes a surprising amount of time just massaging your slides. Little details about making things line up, you know, whether things are justified on the left or whether they're aligned in the center. It takes a surprising amount of time just to fiddle around with different ways of doing that, to actually make something that looks polished. And that polish is something that you want to come across because it makes you look polished. You know, if your slides are sloppy, people will think you think sloppily, regardless of whether that's true. So I think a lot of people would do very well giving talks that just had some sort of statement. It might be a question, it might be a conclusion. It's probably fairly broad compared to the nitty-gritty of what you actually do. Some sort of iconic image, and then just talk. But, you know, like I said, there's a lot of ways to skin this cat. I would probably be tempted to put in a little data, but not too much. This isn't going to be a poster on a slide. This is going to be a couple of things that you use to illustrate really key points. So my lab does both genomics and cell biology, so I have a little bit of each that I could occasionally refer to. I wouldn't necessarily be going through like every subtlety of everything that I should. But this is a fairly common pattern for this sort of thing. It's just like 2 or 3 key things that really help you get across whatever your story is. All right, so general thoughts about making slides and dealing with images or graphical presentations of data or whatever. One is to try to pare things down as best you can to the sparest representation of whatever you're actually trying to get across. And then to highlight, if you can, the key thing that you want people to remember. So I'll show you some examples. So here's a chart. It's just something I pulled off the web from a website that's interested in presenting science and information in general. So a lot of charting programs, Excel is particularly bad about this, by default produce absolutely hideous output. So you can tell just looking at this, right, that this came out of Excel and not MATLAB or R or anything else. And I hope that all of you can recognize immediately all sorts of like obvious flaws in how the information is presented here. So what are some of the ways we could improve this chart? Make it more elegant and less just like visually hideous. Thoughts? This is a participation question.
I can see repetitions, so like the months, I could take off that.
Yeah, do we need this legend here? Not really, because everything's labeled on the bottom, too. Do we need these colors? Not really, because everything's labeled there. Do we need these numbers? Not really, because there's an axis over here. What about these grid lines? Do they fulfill any actual function? It's like, are you also WAPCAC? Your eyes can't just follow over to the side? What about this gray color? Does this gray color add anything? Or the frame around it, does it add anything? None of this stuff adds anything. It just makes it busier. So it's pretty easy to go through anything like this and just look to see, okay, does this graphical element, does it serve any function in getting across the point I'm trying to get across? So we can do that, just strip all that stuff away. This is just a better graph, isn't it? It's less distracting to the eye. It makes it easier to get across whatever you're actually trying to see. So this is what whoever databison.com's improved graph looks like. I looked at this though and I thought, you know, we can actually improve this further still. So one trick I often do is to retitle the chart with the take-home message of what you're actually expected to see in it. So like, if I say rainfall, say, you know, April is the rainiest month, or whatever the point of showing this actually is, then it's implicit that this axis is rainfall, and it just makes your point more clearly. So this is better again, isn't it? April is the rainiest month, In case there's any pedants in the room, I've just delicately labeled that axis as precipitation, even though I think everyone would understand it, even if that's not there. Did I really need to know that these things were in centimeters and not inches or millimeters or what have you? Not really, if the point is just to say that April is the rainiest. So I could strip that away too. And that frame around the outside, that was kind of irritating too, wasn't it? This is cleaner. And the cleaner it is, the easier it is to convey the bit that actually matters. So notice I highlighted the thing that mattered too. And that helps draw your eye in. Okay, this is the big one, right? And the title says it the same. So here it's super obvious. I just flip that up and you know what I'm trying to get across. Whereas I think the messier version, it wasn't clear. Why did I use blue? Because water's, because yeah, water, blue, wet, there's an intuitive connection there too. If this was a chart of like forest fires or something, then maybe I would have used bright orange. And you know, there's not always some intuitive connection between a color. Maybe if I'm talking about a bunch of different things, I might use some distinctive color again and again to highlight, you know, the key thing. But this can be a powerful way to do things. Okay, so this idea that we should strip away everything that's not absolutely essential to portray your data graphically, I think was first really popularized by a guy called Edward Tufte. Has anyone heard of him? A couple of you, maybe the professionals. So he's the author of several really good books on presenting data graphically. The visual display of quantitative information is one of them. Envisioning information is another. He's got 3 or 4 of them. He actually makes a living going around the country giving seminars in how to do this. I've always wanted to go to one, but I never have. They're wonderful books if you want to think about how to show data in the form of pictures in compelling and clear ways. They've really changed how I do this. And, but his really, one of his most important points is this idea of eliminating what he calls chart junk. So all of this stuff, all these grid lines and stuff that don't matter, just get rid of the chart junk and it becomes easier to make your point. I would take that even further. I like to eliminate what I call slide junk. So everything on your slide that doesn't advance your message, get rid of it. The thing that people are particularly egregious about, people love to put the school logo prominently on their slide. So like, you know, this big power cat up on the top left corner. You can if you want to, but it's like you're at K-State 3-minute thesis. Everyone knows you're from K-State. So, or the other thing is showing like funding agency logos down at the bottom. You know, it's great to kind of brag that you have NSF or NIH funding or what have you, but it doesn't really help you get across your point. So for this sort of thing, get rid of all that stuff. Distracting backgrounds, elaborate backgrounds, all these things, get rid of them. Okay, I want to talk a bit about the use of color. So many of you use color in some way. So a lot of people may use microscopy or telescopes or whatever to capture some sort of signal that doesn't actually have a real color in the real world, or it's just some sort of abstract channel of data. So it's something that you ultimately represent as an image, but it's not a photograph of the real world. So you have to think about how you use color to present that data. And something that people are surprisingly ignorant of is that our eyes are radically sensitive, or different in how they sense light of different colors. So this is the exact same image here of a dividing cell, shown in grayscale, in green, in red, and in blue. And you cannot see the same detail in all those images, can you? The blue in particular looks really washed out, and you can't see any of that finer detail in the bottom. The red's a little better, the green is better still, and the grayscale looks the best. And that is literally because your eyes have more green-sensitive photoreceptors in them, and your eyes are particularly insensitive to blue light. So it's very common to see people showing microscopy images in particular with something in a blue channel, and you can't see it. So think very carefully about how you use color, and think about the fact that our eyes perceive different colors quite differently. So if you can, grayscale is almost always the best. Everyone can see it, it's very crisp and clear, and it just works very, very well, unless you have a compelling reason to use other colors. So, oh yeah, this is a subtlety here too. So which do you prefer? Do you prefer that? Or do you prefer that? This one, right? Why?
Simple.
It's simpler, yeah. So I don't know about most of you, but for me, like here I'm really distracted by the strong contrast between the pure white and the black. And then I'm distracted by this grid-like pattern here. And I start staring at the grid instead of the data. You know, why he's being sloppy. That grid there is a little fatter, and that one's, why didn't he organize that? So to my mind, and I think most of you agree, this looks much cleaner. So think about these sorts of little subtleties. You know, don't do elaborate pattern backgrounds, but simple things like whether you're using black or you're using white can really make a big difference. Sometimes we have complex data that we need to map to patterns of colors in some way. This happens a lot in different sorts of science, depending on whether we're talking about an image or sometimes we need to label things, say on a plot or in a map or something like that. So we often have these cases where we need to map some sort of monotonic data to a color pattern. And this is often done for imaging type people, astronomers and microscopists, stuff like that, to convey an image that has a lot of dynamic range, where the brightest things are super, super bright, and the faintest things are super, super faint. And keep in mind that TVs and projectors and stuff like that have very little dynamic range. They've got 6 bits, maybe, of actual dynamic range, for those of you who care about that sort of quantitative detail. And most people's images have much more. So one way you can get around this is to use some sort of colored, pseudo-colored mapping. I would warn you very strongly against using that in something like this for the simple reason that these are extremely unintuitive. If you're not used to thinking on these pseudo-colored maps, this looks totally alien and bizarre, and you're drawn to these subtleties of different colors that ultimately don't mean very much. So if you have to use one, and sometimes you do, try to use a simpler one, like one of these ones here, where there's only a couple colors involved. So sort of, this lookup table here is called red hot. So it goes from red to yellow to white, which is quite intuitive because we're used to thinking about fires and flames in that respect. So there we can really see that this stuff's extra bright, but we still have lots of texture here. And for those of you who do a lot of this sort of mapping between data and colors, there's actually a whole field of study devoted to this at the intersection of graphic design and neuroscience and psychology. And there's been a lot of really good recent work in terms of how to really design good color maps to map data to color schemes. So I prefer these simpler ones, like this one here that goes from red to white, to these really complicated ones for various reasons. But even these simpler ones you can improve. So, you know, these multicolored patterns, they tend to introduce detail to the image or the mapping or whatever that doesn't actually matter. Like here, turquoise and green right next to each other, they look really different to your eye, right? Your eye said, oh, turquoise, green, those are totally different things. But in terms of this mapping here of the underlying data, they're actually right next to one another. So it's not providing a very intuitive reflection of what it's meant to be doing. So people have made more recently what are called perceptually uniform color maps, which are color maps where they actually try to take into account how our brains work in various ways, how we perceive color, to provide smoother and more representative mappings. So I'm getting kind of technical here. This is probably irrelevant to a lot of people in the room. But if you just Google perceptually uniform color maps, you can find really good ones that you can use depending on whether you're working in R or MATLAB or whatever. These subtleties can really matter. Okay, another place where color comes up a lot is in multicolor images, so especially in microscopy. People very often, but other fields too, very often have some sort of image or whatever that has multiple channels, and you want to show them, so you use different colors. Our computers, you know, define color in terms of red, green, and blue, so people often intuitively want to do the same. So especially in cell biology presentations, you'll often see 3 channels presented, one in green, one in red, one in blue. So blue, I've already said, is kind of a bad channel to be using just because it's so faint in general to your eye. But the red-green color combination has other problems. Can everyone actually in the room actually see the difference between the red and green here? So about 10% of men, 5-ish% of the population overall has a deficiency in color vision, most often difficulties in telling the difference between red and green. So if you want 5% of your audience to definitely not get the point, using red and green as your key color pairs is probably a good way to do it. So there are other color pairs that work better for the colorblind. Green and magenta, for example, is a good one. There's no reason you have to be confined to primary colors, though, whether they're CMYC or RGB or whatever. For example, I often use white and green for my work. And I use the white here to stain all the cells in the embryo, and then the green is used for the channel that's highlighting particular cells. And that makes sense for me because these 2 colors aren't equally important. I mean, I could show them in magenta and green and it would look fine. But here the white, it's very easy to see and see the embryo, but kind of fades into the background. And having just one colorful color really highlights the cells that I actually care about. So subtleties here about how we perceive color can really influence how your images look. Okay, so I'm not very good in general with dealing with colors. If I need to label a bunch of data points on a graph and I'm trying to pick out, a nice color palette to do that, if I just start picking colors at random or just sort of using my eye to pick them, I usually do a really, really bad job because that's not where my talents in life lay. There's a great web resource for picking nice color patterns, and it's called colorbrewer.org. Let's see if this computer will take me there. Microsoft PowerPoint has stopped working. All right. So it's a little web app that lets you define the sort of data you're thinking about. So it can define the number of classes that you're trying to show. So I might set that here to 5. So now it's got some finer gradations of color there. It lets you define the nature of your data. So whether it's sequential in nature, so something that's proceeding along some sort of path, whether it's diverging in nature, which data often is. So here it's going like white would kind of be the midpoint of whatever's being portrayed, and it's getting either progressively more bluish or progressively more brownish. Or whether it's a qualitative set of data, where it's just data points that you want to make look different and stand out from one another. So it lets you set the number of data classes, set the type of data. It lets you go through some different palettes and see which ones look better or worse. And then it's also got checkboxes here so that you can get, I guess it didn't like any of them being colorblind safe, but you can click the colorblind safe box there and get rid of all the color palettes that aren't colorblind safe. And then you can take this and you can actually export these colors as like Adobe swatches, or you can just copy down the RGB combinations or whatever. So I found this website really, really super helpful in terms of designing good color schemes to use in my presentations. And I believe for people who are a little more computationally savvy than I are, I think there's like R packages and stuff that let you do some of this programmatically. All right, let's see if I can get back to my talk. Okay, so I guess my take-home message there is think carefully about your use of color. First of all, is it actually needed at all? So if you just like throw colors around too liberally, I think they'll end up distracting more than they help. Often just simple grayscale, a little bit of color here and there to really draw your eye to the things that really matter. This issue of perceived brightness between different colors is surprisingly important. And try to use colors in a way that's intuitive. on some level, and keep in mind how it'll work for the colorblind. So I think my parting point is just to say that you should, in general, and this isn't so much thinking about what you can do between now and when you give your 3-minute thesis, but just every day as a scientist or a scholar or whatever, try to think about how you can make either yourself or identify out there wherever what I think about is iconic images that capture the spirit of your work in some way. So these are a little different than data, because the data you acquire is often optimized in some way to balance like how quick you can acquire it, and it's not necessarily being generated in a way that's optimized to give you the most stunning, striking, compelling image that you can throw up on a slide. So every once in a while, it's well worth taking the time. Say if you're a microscopist, to get this one image, not because you need it to prove some scientific point, but because you're going to optimize image quality in every conceivable way, you know, turn up the magnification, great signal to noise, just to make the most awesome image you can. And those are the things that you use for cover images, for journal submissions, that you use in talks like this, and that they can really help you build your career. That said, if you're not a scientist, or your work is framed differently, these images are out there. It might be images of you working out in the field. It might be images of your artwork. It might be, historical maps if you're a historian, whatever. But there's something out there that is visual and that helps to define your work. And these are the things you want to be thinking about incorporating in these sorts of talks. So thanks very much. Questions on the graphical side of things? No? Okay, thank you.
Does anyone have any other questions for any of the presenters?
Thank you, that was helpful.
Yes, hopefully I know just a few, I think less than half of you that are here are participating in 3MT, but hopefully even if you're not, you found today's seminar helpful. And also if you're not presenting in 3MT, if you are, on our 3MT webpage, we have other resources, some that Sarah referenced. Those are there and open to the public. So even if you're not doing 3MT, you're welcome to utilize those resources to help you in any situation where you're working on practicing your communication. For those of you that are doing 3MT regarding the slide, as Dr. Beeman mentioned, you do have one static slide that you can use for that competition. If you are participating, you should have gotten an email from me yesterday afternoon with some details about presenting. We will create a title slide for you with your presentation title and your name, so you don't have to include that on your presentation slide. You're welcome to, or you're welcome to include another type of statement or some other text if you'd like. But again, keeping it simple is best for that. And I also strongly encourage you, again, whether or not you're participating in 3MT, but to check out some videos from past participants. We have videos from winners from our competition from the last 2 years. We also have a link to the University of Queensland site, which started the 3-minute thesis competition. They have tons of other 3MT winner videos on there. And so that's a great way to see kind of like what a good 3MT presentation should look like. So if you are participating in 3MT, if you have any questions, you're welcome to chat with me. But and again, for the professional development certificate, you'll receive a link to a feedback survey that you'll need to complete in order to get your credit for the certificate. But otherwise, thank you for coming, and please help me thank our presenters again for being here today.
It's okay. I